In 2026, air power remains one of the strongest symbols of military dominance, technological advancement, and national security, and at the heart of this power are the world's most advanced fighter jets. Modern air forces no longer rely on speed alone. Today's fighter aircraft are flying command centers, combining stealth, artificial intelligence, sensor fusion, electronic warfare, and precision strike capabilities into a single platform. When we look at the top 10 most powerful fighter jets in the world in 2026, we're not just comparing machines, but entire defense philosophies and levels of technological maturity. The United States continues to dominate global air power with aircraft designed for full-spectrum warfare. Fifth-generation fighters like the F-22 Raptor and F-35 Lightning II set the benchmark for stealth and situational awareness. These jets are designed to see the enemy first, strike first, and disappear before being detected. Their strength lies not only in radar and visibility, but also in their ability to share battlefield data instantly with other aircraft, drones, and ground systems, creating an overwhelming information advantage. Close behind are advanced fighters from other major powers, such as Russia and China, which have invested heavily in countering Western air dominance. Aircraft like Russia's Su-57 and China's J-20 emphasize long-range missiles, high maneuverability, and powerful radar systems. These jets are built to challenge stealth aircraft by detecting them at greater distances and engaging targets beyond visual range, signaling a shift toward long-range aerial combat rather than traditional dogfights. European fighters also play a critical role in the global air power balance. Jets such as the Eurofighter Typhoon, Rafale, and Gripen E demonstrate how versatility and multi-role capability define modern warfare. These aircraft excel in air superiority, ground attack, and maritime strike missions, often with lower operating costs and exceptional adaptability. Their advanced avionics and weapons integration make them highly attractive to air forces seeking cutting-edge performance without the expense of stealth-focused platforms. Another key factor in ranking the world's most powerful fighter jets is weapons integration. Modern fighters carry highly advanced air-to-air missiles, precision-guided bombs, and standoff weapons capable of striking targets hundreds of kilometers away. The combination of long-range weapons and advanced targeting systems means that battles may be decided before pilots ever see each other, changing the nature of air combat forever. Equally important is pilot survivability and aircraft endurance. Modern jets are built with advanced electronic warfare systems that can jam enemy radars, deceive missiles, and protect pilots in the most hostile environments. Combined with aerial refueling capability and networked operations, these fighters can operate deep inside contested airspace for extended periods, giving air forces unmatched strategic reach. Ultimately, the ranking of the top 10 most powerful fighter jets in 2026 reflects more than raw performance. It reflects a nation's ability to innovate, integrate technology, train pilots, and sustain long-term air operations. In an era where control of the skies can determine the outcome of conflicts, these fighter jets represent the sharp edge of military power and the future of global security.
Air power in 2026 is no longer measured by how fast a fighter jet can fly or how many weapons it can carry. It is defined by the technology that connects every element of the battlefield into one intelligent system. Modern aircraft act as flying command centers using advanced sensors, radar fusion, artificial intelligence, and real-time data sharing to detect threats long before they are seen by the enemy. Stealth technology reduces radar visibility, while electronic warfare systems disrupt and confuse opposing defenses, allowing pilots to operate safely in hostile airspace. Precision-guided weapons and long-range missiles ensure that engagements can be decided from hundreds of kilometers away, minimizing risk while maximizing effectiveness. In this new era, technological superiority gives air forces decisive control, proving that information, connectivity, and innovation matter far more than raw speed or firepower alone. Fifth-generation fighters dominate modern air combat primarily because stealth allows them to operate where older aircraft simply cannot. Advanced airframe design, radar-absorbent materials, and internal weapons bays dramatically reduce radar cross-section, making these jets extremely difficult to detect and track. This invisibility does not make them invincible, but it gives pilots a critical first-look advantage, allowing them to enter contested airspace, identify threats, and position themselves without alerting enemy defenses. Beyond physical stealth, fifth-generation fighters achieve dominance through sensor fusion, which transforms massive amounts of battlefield data into a single, clear picture for the pilot. Information from radar, infrared sensors, electronic surveillance, satellites, and allied platforms is automatically analyzed and displayed in real time. Instead of managing multiple screens and systems, pilots receive a simplified yet highly accurate view of the combat environment, enabling faster and more confident decision-making under pressure. Information superiority also comes from unmatched networking capabilities. Fifth-generation fighters can share data with other aircraft, ground forces, naval units, and unmanned systems. This creates a connected combat network where one jet's sensors can guide another jet's weapons, even if that second aircraft never activates its own radar. Such cooperation multiplies combat effectiveness and allows air forces to strike targets with precision while remaining largely undetected. Electronic warfare integration also creates a key advantage. Fifth-generation fighters are designed to detect, jam, deceive, and suppress enemy radar and communication systems automatically. Instead of relying on specialized support aircraft, these jets carry their own electronic warfare capabilities, enabling them to disrupt enemy defenses while simultaneously conducting air-to-air and air-to-ground missions. This self-contained survivability greatly increases mission success in high-threat environments. Artificial intelligence and automation further enhance the dominance of fifth-generation fighters. AI assists pilots by prioritizing threats, managing sensor data, and recommending optimal tactics in real time. This reduces cognitive load and allows pilots to focus on strategy rather than system management. As air combat becomes faster and more complex, this human-machine teamwork provides a decisive edge over less advanced aircraft. Ultimately, the dominance of fifth-generation fighters comes from the combination of stealth and information control. By seeing the battlefield first, sharing intelligence instantly, and striking with precision before the enemy can react, these aircraft redefine air superiority. In modern warfare, control of information is control of the skies, and fifth-generation fighters are built to own that advantage. Russia and China have shaped their modern fighter development around a strategic focus on long-range detection and missile-based combat, aiming to challenge Western stealth dominance. Rather than relying solely on radar and visibility, their approach emphasizes powerful sensors capable of detecting targets at extended distances, including stealth aircraft. Advanced radar systems such as active electronically scanned arrays and infrared search and track sensors allow these fighters to locate enemy aircraft without emitting signals that could reveal their own position. Long-range engagement is central to this doctrine. Russian and Chinese fighters are designed to carry heavy, high-speed air-to-air missiles capable of striking targets well beyond visual range. These missiles are often larger and longer range than their Western counterparts, enabling pilots to engage adversaries before close combat ever becomes necessary. This strategy reduces dependence on dogfighting and places greater importance on early detection, targeting accuracy, and coordinated missile launches. Another critical element is the integration of ground-based and airborne detection systems. Fighters from Russia and China often operate as part of a broader air defense network that includes early warning aircraft, surface-based radars, and missile systems. This layered approach extends situational awareness across vast regions, allowing pilots to receive targeting data from external sources and launch missiles without relying entirely on their own onboard sensors. Electronic warfare also plays a major role in this strategy. Both nations invest heavily in jamming, signal disruption, and radar counters to degrade enemy awareness and reduce the effectiveness of stealth technology. By interfering with communications and sensor systems, these fighters aim to create openings for long-range missile strikes while minimizing exposure to return fire. High altitude and high speed performance further supports missile combat effectiveness. Russian and Chinese fighters are often optimized for operating at extreme altitudes, where thinner air increases missile range and kinetic energy. This design choice enhances the reach and lethality of their weapons, reinforcing their emphasis on beyond visual range dominance rather than close-range maneuvering. Overall, Russia and China view modern air combat as a contest of detection, range, and coordination. By prioritizing powerful sensors, networks defenses, and long-range missiles, they seek to counter stealth-focused aircraft and reshape aerial warfare into engagements decided at great distances, where information and missile reach matter more than traditional dogfighting. European fighters are designed with a strong emphasis on versatility, allowing a single aircraft type to perform multiple missions effectively without the need for specialized platforms. Jets such as the Eurofighter Typhoon, Rafale, and Gripen can switch between air superiority, ground attack, reconnaissance, and maritime strike roles within the same mission. This flexibility is especially valuable for air forces that must respond